Bismillahirrahmanirrahim. Assalamu alaikum everyone. So here we are continuing with the problems we are facing in chapter number 6. This video is particularly directed for question number 19 in particular. So the question reads, write a MATLAB program in a script file that finds and displays all the numbers between 100 and 999 whose product of digits is 6 times the sum of the digits. For an example, it's in the question it says that 347 is that number that you will be finding. And why is 347 that number, that desired number? So notice the product of each number 347, each in digit, in fact each digit in the number 347, 3 multiplied by 4 multiplied by 7 is actually equal to 6 times the sum of the digits 3 plus 4 plus 7. Fine. So you are to find all such numbers which lie between 999. Fine. Now the question is saying that you are to use a for and loop in the program. Why? Because you have to begin from 100, you have to end at 999. So that's what you are sure of, that you have to repeat the loop for from 100 all the way to 999 with a constant spacing of 1. So we know for a start, for now, that we have to follow, we have to use the for and loop. The index variable that you're going to use, for example, I have used k here, you can use any other variable. I have to begin from 100, I have to end at 999. It is giving an error. Why? Because like I told you earlier, for every for there has to be a corresponding end. Now this is what we have begun with, this is what the question has guided us. Now we need to find out that k, that very k, which is, for example, 347, a number whose digits, the product of each digits is actually equal to the 6 times the sum of each digit. Now the problem is here that if we identify this number, this number is 347 whole, right? Now what we are going to do is, from this number 347, or as we have used the variable k for k in our case, what we are going to do is we are going to trim, if we can use the term trim here, we are going to isolate or trim each digit from the variable k. So if, for example, let's say I'm going to use the command window entirely here. So for example, my number is, for example, my number is 347 here, right? So what I'm going to do next is, from the 347, I'm going to isolate each digit. For example, 3, then 4, then 7, and I'm going to save them in individual variables. So for example, for the first one, I will be using the variable x. For the second one, I'll be using the variable y, and for the third one, I'll be using the variable z, right? Now, how to isolate in the first place? And this is simple mathematics, you're already aware of it. So what I'm doing here is, because I want to isolate the very first number. Now this is, mind you, this is a unit position, this is the 10th position, and this is the 100th, right? So in order to obtain this 3, what I'm doing is, k is my variable name, I'm dividing it by 100. Now notice what will happen is, you will obtain 3.47, right? Now this 3.47, say I want to extract this number 3. Now you all know these two functions, fix and floor, right? So fix and floor, both functions will be able to pick or isolate this number 3. So if I talk about this number in particular, 3, the first position, fine, because notice all the numbers of k from 100 all the way to 99 will be 3 digits number. That means the highest position it can take up to will be the 100 position. So what I'm doing is, from k, I'm isolating this 3 and I'm saving it in the variable of x. And how I'm doing it? I am dividing k by 100 first. When I'll divide it by 100, I'll obtain a decimal point, decimal number 3.47. From that, I'll be using the function fix to isolate the very first digit, which is 3 here. Next, I have to isolate the number 4 here. In order to isolate the number 4, what I'm going to do is, the original number is 347. The original number is 347. I have already obtained 3, which was in the 100 position. So if you notice, this 100 position x, this x, if I multiply x by 100, right? So this is essentially what I am subtracting 300 from 347, which is my original number. So I'll be getting 47. Now this 47 I want to isolate the 10th wala position wala element. So how I'm going to do so is that I'm going to divide 47 by 10. When I do so, I want to isolate this number 4 from this decimal number. Again, I'm going to use the function fix to help me isolate the number 4 here. So essentially what I did to isolate the second number, the second in the place of 10, what I did is I used the variable y. The initial number was k and x is already saved, which is 3 here. I multiplied x by 100. This number, if you notice, this number 347, this number is what? 347 minus 300, which is going to give you 47. Next, I'm going to divide this 47 number by 10. How? By dividing it by 10. When I divide it by 10, I will obtain 4.7. From the 4.7, I want to isolate this number. And how I'm going to do so is I'm going to use the function fix. So now I'll obtain the number 4. So far 3 has been saved, isolated in the variable x. 4 has been isolated in the variable y. Now what next? I have to use the variable z in order to save the third digit, which is 7. So essentially what I'm going to do is this, the actual variable, the initial number was k. In k had what? 347, right? Now so far I have obtained 300, 3. I have also obtained 4, which is 40. So what I'm going to do is I'm going to subtract x times 100, which is 300. Which is what? 300, right? 3 times 100. This will give me the number 47. Then I'm also going to subtract 4 times 10 because it's in the 10th position. So minus y times 10. Fine. So 47 minus 40 will give you what? 7. So in this particular expression, you're going to save in the variable z. You do not have to apply any function here. It will directly give you the number, the third number. It will directly isolate the third digit. So this is essentially what you're going to do here as well. So in order to isolate each individual digit, what I'm going to do here is I'm going to use the variable x, variable y, variable z. Variable x will be used for the first digit. Variable y will be used for the second digit. And variable z will be used for the third digit. So what I'm doing here now is, so xk is my actual initial number. I'm going to divide it by 100. It will give me a decimal number. In order to isolate the first digit, which is closer to 0, I'm going to use the function fix. You can either use the function floor also. Then similarly for the y, what I'm going to do is I have already obtained the number, the first digit here. Now in order to obtain the second digit here, what I'm going to do is initial number minus the x in the 100 position that I have obtained. So minus x times 100, which is for example the first digit multiplied by 100. Then I'm going to divide it by 10 here, and this entire number will give me a decimal number. From that decimal number, I want to isolate that integer which is in the second place, so I'm going to use the function fix. Last, the third digit, what I'll do is that I will use the initial variable, which was k. I will subtract x times 100. I will subtract x times 100. I'll also subtract y times 100 from it, y times 10 from it in fact, in order to get the value of z. So this x, y, z will be the individual the individual isolated digits from the variable a. Now, what I need to do is I need to obtain those special numbers whose properties are that their product, yani x into y into z, is actually 6 times x plus y plus z. So, what I'm going to do next is, I'm going to use if conditional expressions here, and what I'll say is I'll say that if x times y times z is actually equal to 6 times the sum of x, y plus z, then give me that number. And what is that number? A. And for every for there has to be a corresponding end. Similarly, for every if there has to be a corresponding end. So let's run this first. Let's dock our command window here, and I'm going to show you the result in a while. It's Z here. Wait a minute. Yeah, so there was an extra character here. Anyway, so this is the result. Fine. If you notice that 347 is the part of the answer. Now, if you want, you can save this kk as part of an vector. How you can do so is assign, for example, I. Initially, since you do not have any such number, you can assign I as an index or the position for a vector that you're going to create as A. And then every time if happens, what you can do is every time this condition is fulfilled, you can reassign the index value as I plus 1. So in the first instance, I's value is 0. So 0 plus 1 will be 1. So assign, for example, the ith position of A, which will be, let's change the variable as A. It's fine. So assign a vector name by the variable name A, and save the value of A into it. So the A is a new variable. Its ith position will be defined how by that number, which is A. A is which number whose individual digits products, the products of individual digits is equal to this is 6 times the summation of the individual digits. So I'm going to put a suppressor here, also a suppressor here. I'll come out of the loop and I'll ask it to display the variable A. So let's run the program now. See, now you will get to see all these such given elements who will be fulfilling this characteristics as part of a vector, which will be a very good representation. So if you notice, for example, A, very first element 268, let's check it. So the product 2 times 6 times 8, this is this. And if we do the sum of 2 plus 6 plus 8 and multiplied by 6, you will get to see that it's the same result. So these are all the numbers that are required, and this is the final result. That's all. Thank you.